will discuss question bank module 1. After completing, one student asked me to explain about lead acid battery and lithium ion battery. That 2 batteries will discuss. Okay, na?
Okay, ma'am.
Okay. So in question bank, you have to follow the question bank. First unit electrochemistry and corrosion. Second unit water technology. Third unit you have to prepare only up to polymers, biodegradable polymers. So in question bank there are part A, part B, part C. Okay, 3 parts are there. Part A short answer questions, part B long answer questions, part C problem solving and critical thinking questions. And you got the question paper also. Question paper pattern you got already in Telegram. Okay, so means we are getting 5 questions. So first question A, B are there. So A question will be long answer question, okay, theoretical question, and B question will be that is you will get either critical thinking question or problem solving. Means you have to concentrate in part B and part C. So part A, 20 questions are there. So just I will read.
I need to study part C also.
Part C only you have to study. Part B and part C.
Part A no need.
No need. Part B, part C. Understood?
Yes, ma'am.
You will get part B for 2 marks, part C for 3 marks. But how much content is there exactly you have to write. You will get enough time. Okay, na? So don't write like a short answer type, because it will be useful for SE exams also. You prepare, okay, how the question, how the content is there, how much content is there exactly, that much you have to prepare and you have to write also. Okay, just I will tell the students part A questions, just I will read, then we'll go to part B. Okay, na? Define the terms electrochemical and electrolytic cell. What is electrochemical cell? Students, what is electrochemical cell? Hello?
Which converts the chemical energy into electrical energy.
A cell which converts chemical energy into electrical energy. Electrolytic cell?
Which converts
Electrical
Electrical energy
to chemical energy.
Chemical energy. Okay. So what is the role of the salt bridge in voltaic cell? What is the function of salt bridge?
With
Neutrality.
provides the neutrality of the solution.
Both the solutions. Okay. Okay. In both the half cells, anodic half cell, cathodic half cell. Okay. What is the EMF of the galvanic cell? Definition.
Maximum potential difference.
The maximum potential difference between two electrodes. Between 2 electrodes in a cell. Okay. How to represent galvanic cell? How you will write cell representation?
Anode bridge.
Anode, which side you will write? Anode, which side you will write?
Left side.
Anode, which side are there? Anode, which side representation of a cell? Hello? Very simple, ma. You know how to represent a galvanic cell.
Yes, ma'am.
Anode, which side you will write? Cathode, which side you will write? Tell me. See,
Anode
left hand side electrode is there. Right hand side electrode is there. Then how you will write? Tell me now.
And anode is in copper.
Anode is copper.
Anode zinc, ma'am.
Anode is zinc. Cathode is
Copper.
copper. How you will write? Tell me. We are taking zinc electrode in zinc sulfate solution, copper electrode in copper sulfate solution. Okay, na? And we are connecting these 2 solutions with a salt bridge. And 2 electrodes we are connecting to the voltmeter. Now tell me representation of a cell. Representation of a cell. Hello, students. Anode, which side you will write? Tell me.
Left.
Left.
Left side.
Cathode.
Right.
Right. Anode, what we have taken? Tell me.
Zinc electrode, zinc
Zinc
solution.
electrode in zinc sulfate. How you will write? First you will write electrolyte or electrode?
Electrode.
Electrode you will write first. Okay, electrode, zinc. Then
Electrolyte.
electrolyte you will write. Electrolyte. Okay.
In
Then
cathode, we will
right
first
side you
write
tell me. Right side you tell me.
Electrolyte.
Electrolyte, first you will
Electrolyte,
write.
then
Means copper
electrode.
And then
sulfate you will write.
electrode.
Copper sulfate. Then you will write
Electrode.
electrode. Okay. So these two are connected with the
Salt bridge.
salt bridge, indicated by
Double line.
double line, double slash, double line, double vertical line. Okay. So we will write anode always left side, cathode always right side. So anode we will write electrolyte, electrode, electrolyte, electrode, electrolyte, and cathode side we will write electrolyte, electrode, oppositely, electrolyte, electrode. So these two half cells, what we are taking half cells that are connected with the salt bridge, that is with a double vertical line. So that is the representation of a galvanic cell. It is not given here in the diagram. Here also it is not. Okay, it's not there here. Okay. You just once you see that representation of a galvanic cell. Okay, na? So you have to write anode electrode, electrolyte, cathode electrolyte, electrode, and that two are connected with a salt bridge with a double vertical line. What is battery, ma? Students, what is battery?
Of cells connected in
Combination of cells.
Combination of the cells connected in series.
Series.
How they are classified? How many are there? Batteries are classified into
Two types.
Primary,
Two
secondary.
types.
primary batteries and secondary batteries. Okay. You tell any 2 points, ma, differences, primary batteries, secondary batteries. Some 2 points.
Primary are temporary.
Huh?
Temporary. For temporary use, you will use, ma'am.
They cannot be recharged.
You should not tell temporary.
We
Primary
cannot
batteries
recharge
are,
it.
primary
Not
batteries
rechargeable.
are
Single use.
single use, non-rechargeable batteries.
Non-rechargeable.
Secondary batteries are
recharge.
rechargeable batteries, multi-cycle use. We can use
Primary are cheap, secondary are costly.
costly. Okay, okay. Tell me some other point. You tell me. Expensive and cheap. You told okay. Let's
Cell
see.
reaction cannot be reversed.
Cell reaction cannot be reversible. Means which reaction takes place, ma? Here in primary cells, there are
Electrochemical.
two electrochemical. It will act as only
Discharging.
Only discharge.
only
Discharge.
discharging. Only discharging reaction is taking place, ma, not charging. Only discharging reaction. If you apply electricity also, it does not work. Only discharging reaction. What is discharging reaction, students? What is
Electrochemical.
discharging reaction? What is discharging reaction?
Electrochemical.
Electrochemical cell only. Tell me, what is the reaction takes place?
Chemical energy to electrical energy is called
Chemical energy to electrical energy. Chemical energy converts into electrical energy during discharging reaction. Now, charging reaction means
Electrical to
converted
chemical.
into electrical.
energy to chemical energy. Electrical energy to chemical energy. Okay, you learn some differences, ma, primary cells and secondary cells. So in primary cells, it will act as only electrochemical cell. Voltaic cell means the reactants are converting into products, produce electrical energy. Whereas secondary cells, these are rechargeable batteries, rechargeable cells, where discharging reaction and charging reaction is taking place here in secondary batteries. Next question will say, explain discharging and charging reactions of lead acid battery. So, discharging reaction. What are the what is anode, cathode, electrolyte in lead acid battery? Anybody? What is anode, cathode, and electrolyte in lead acid battery?
PB, PbO2, and 21.4%.
PbO2. Anode, cathode, electrolyte.
21.4% H2SO.
Dilute H2SO4. So we are taking anode is lead, cathode is lead oxide, and electrolyte is dilute H2SO4 we are taking. Okay. So here the question is in short answers. Explain the discharging and charging reactions of lead acid battery. Only we have to write discharging reaction and charging reaction. Okay. So what happens at anode during discharging is, okay. So here lead, it is undergoing oxidation reaction. Okay. Losing electrons. Okay. And Pb2 plus ions react with sulfate ions and forming lead sulfate at anode. Lead sulfate, the product lead sulfate at anode. So at cathode, what is the reaction taking place during discharging is what we are taking at anode, at cathode is lead oxide. Okay, ma? So this lead oxide is taking electrons, gaining electrons in presence of electrolyte, in presence of H2SO4. Okay, and reduced to what we are getting here, lead sulfate. Again, lead sulfate is forming at the cathode plus 2H2O. So we got here at anode lead sulfate, at cathode lead sulfate during discharging reaction. So during discharging reaction, chemical energy converted into electrical energy. So what are the chemicals we used in this battery? Lead, lead dioxide, and dilute H2SO4. Okay. So we can write the net reaction here, Pb plus PbO2 plus 4H plus 2SO4 2 minus gives rise to 2 PbSO4 plus 2H2O plus electrical energy. Okay, so this is the discharging reaction. So discharging reaction is nothing but reactants are converting into products. Chemical energy is converted into electrical energy. So whereas charging reaction, see, here we are supplying electrical energy. Okay, we are supplying electrical energy to convert a product into reactants. To convert product into reactants, nothing but we are using electrical energy. So to convert into chemical energy. To convert into chemical energy is nothing but, so to get the originated chemicals here, lead, lead dioxide, and dilute H2SO4. So we are supplying electrical energy here. Okay, and here we are getting when the reaction is taking place, we are getting lead plus sulfate ion. Okay, so next we are getting lead sulfate in presence of H2SO4 at anode. We are getting lead dioxide plus 4H plus sulfate ion plus here 2 electrons. So here electrical energy converts into chemical energy. So net reaction you can write 2 PbSO4 plus 2H2O plus supplying energy, electrical energy, converts into lead plus lead dioxide, PbO2 plus 4H plus sulfate ions. So 2S4 2 minus. So these are the reactants we got here during charging reaction. Okay, so products are converted into reactants. So these reactions, this you have to write. Okay, na? Discharging reaction and charging reactions, and write the advantages and applications of lithium ion battery. What are the advantages of lithium ion battery and advantages and applications? So it is like advantages means long shelf life, we can use more period of time, and low maintenance, we can maintain easily, low self discharge. Okay, low self discharge, discharging reaction means there won't be any self discharge, low self discharge, high energy density. These are the advantages of lithium ion battery. So disadvantages are there, but here the question is only advantages that you write. Only advantages. Advantages and applications. Okay. This PPT I will send you more. Okay. If you get any doubt, you can see. So applications are laptops, cellular phones or mobile phones, electric vehicles. So these are the applications of lithium ion battery. So next question, what is single electrode potential? Students, what is electrode potential? Can you answer? We discussed electrode potential.
Potential difference.
When any electrode is dipped in its own electrolyte solution, tell me what happens. What is single electrode potential? I am not asking standard electrode potential. What is electrode potential? Tell me. What is electrode potential? When you are dipping electrode in electrolyte, what happens?
difference between the
It depends on nature of electrode only. Tell me, what is electrode potential? What reaction takes place?
Oxidation or reduction?
Oxidation or reduction. Very good, ma'am. Who told that? Who is that? 57, huh? Hello? 31. So oxidation or reduction reaction takes place, depends on the nature of the electrode. Now tell me definition of electrode potential. Definition. Hello, what is electrode potential?
Potential difference between electrode and electrolytic solution.
Potential difference between electrode and electrolytic solution. Potential difference between electrode and electrolyte solution. So if electrode is undergoing oxidation, electrode will lose electrons. Electrode will lose electrons. If electrode is undergoing reduction, okay. So electrode, the electrolyte means what we are taking the electrolytic salt solution. From that, the ions, okay. For example, cation Cu2 plus ions, it will gain electrons, okay, and it will reduce to copper. Means depending on nature of the electrode, either it will undergo oxidation or reduction. So we can write here the definition. The potential difference between electrode and electrolyte is known as electrode potential. Okay. So how do you determine the electrode potential of zinc in zinc sulfate? How to find out zinc electrode potential? Students, how to find out zinc electrode potential? By connecting to SHE. By connecting to, what is SHE?
standard
Standard hydrogen.
Standard hydrogen electrode. What is its potential?
0.
Zero.
Its potential is 0. So these two electrodes, how you are connecting? Tell me. SHE and zinc electrode, how you are connecting? You are connecting to? You are connecting to? You are connecting to? Where you are connecting? Where you will connect, ma? You will connect to voltmeter, yes or no? Hello?
Yes, ma'am.
You will connect to voltmeter, standard hydrogen electrode and zinc electrode. Okay, both half cells. Okay, you are connecting to voltmeter, and this zinc sulfate solution and what we are taking in hydrogen electrode, that is HCl solution, that are connecting with the salt bridge. Okay, then you can find out electrode potential of zinc. Let me see. You can see here, everybody, students.
Yes, ma'am.
You can see standard hydrogen electrode and zinc electrode and connecting to the voltmeter, and these two solutions are connecting with the salt bridge. Students, all of you, can you see the diagram?
Yes, ma'am.
Yes, ma'am.
You will get zinc electrode potential. Okay. Hello. Hello.
Yes, ma'am.
In this zinc will undergo oxidation reaction, and hydrogen electrode, it will undergo reduction reaction. You can see the reactions. Zinc is undergoing oxidation reaction, losing electrons from zinc electrode. Everybody is seeing the reaction? Yes or no? Zn gives rise to
Zn2 plus
2
2
electron.
electron.
Zn2 plus 2 electron. The 2 electrons are taken by, gained by hydrogen, H plus ions, 2 H plus ions reduced to
Hydrogen gas.
Okay. So here we are taking to find out zinc electrode potential. We are connecting to the standard hydrogen electrode. Okay. The 2 electrodes we are connecting to voltmeter, and the 2 solutions we are connecting with the salt bridge. Okay. Then we can find out electrode potential of zinc. Okay. What is the formula to find, to calculate? E cell formula, tell me. Hello.
E cathode minus E anode.
E cathode minus E anode. Now tell me which is anode, which is cathode in this cell. Hello students, which is anode, which is cathode? In the cell, which is anode, which is cathode?
Zinc sulfate solution is cathode.
Zinc electrode, that is zinc electrode is cathode.
Cathode.
Anode.
Zinc electrode is
Cathode.
Anode.
cathode, anode.
Anode.
What is the reaction? Anode means, tell me first. What is the reaction takes place?
Oxidation.
Oxidation.
Oxidation. Okay. Oxidation means what? What is oxidation reaction?
Losing of electron.
Loss of electrons. Loss of electrons. Okay. So zinc, it is losing electrons, undergoing oxidation reaction. It will act as anode. Now here standard hydrogen electrode act as a
Cathode.
cathode. What is cathode reaction means? What is the reduction reaction?
Gaining of electron.
Gaining of electrons. Reduction reaction means gaining of electrons. Okay, ma, you know what is anode, what is cathode? Anode, at anode, oxidation reaction takes place. At cathode, reduction reaction takes place. Now tell me the formula again. Tell me the formula. Students, tell me the formula.
E cathode minus E anode.
E cell is equal to
E cathode minus E
minus E
anode.
anode.
minus E anode. Now tell me, here cathode is, you told, standard hydrogen electrode. What is the potential?
0.
0. Okay, 0 minus, what is the potential you got here? Zinc. What is the potential you got? 0.76.
76.
Okay, you can calculate now. You can calculate ma electrode potential of zinc. Okay, now. Next ma. Define electrochemical series. What is the definition ma? Electrochemical series? What is the definition of electrochemical series? Students?
When elements are arranged in increasing order of the standard electrode potential.
Elements are arranged. Okay, elements are arranged in the increasing order of standard reduction potential. Standard
Electrode potential.
Standard electrode potential. Okay, or standard reduction electrode potential, you can write. Standard reduction electrode potential. So an elements are arranged in the increasing order of standard reduction electrode potential is known as electrochemical series. Now next, what is the question? Applications. Tell any two applications, students. From electrochemical series, what you are able to know? Students, tell 2 points, you tell me.
To predict the relative oxidizing and
reducing power. So we will be able to know that which metal is undergoing oxidation reaction, which metal is undergoing reduction reaction. Okay, so that we will come to know by knowing their electrode potential values. Okay, next, any other point? First is to predict the relative oxidizing and reducing powers. Very good.
Predict wherever it will react with acid to give hydrogen gas.
To predict whether a metal will react with acid to give hydrogen gas. See ma, all the metals which are placed above hydrogen, okay, so they will react with acid, okay, to give, they will give, after reacting with acid, they will give hydrogen gas. All the metals which are placed above hydrogen. So learn application, students. Now derive Nernst equation for the calculation of electrode potential. So you have to learn that derivation part. Okay, no, I didn't give it here. Derivation part is not there. Learn everybody Nernst equation compulsory. You have to learn derivation. Now describe the construction of calomel electrode with a neat diagram. Hello, students. Hello.
Yes, ma'am.
Construction, tell me. You remembered a very simple construction. Calomel electrode, tell me. Construction.
Calomel electrode is made up with the glass tube.
Glass tube, we are taking a long glass tube. Okay. First point, long glass tube. What you are filling in the glass tube? What you are filling?
Paste of
First you will take paste, Students, what you will fill in the glass tube?
KCl solution.
What you will fill in the long glass tube? Tell me. First, what you will fill?
Mercury.
at the bottom.
Mercury you will fill. Then
paste of
Of mercury chloride and
mercurous chloride. Paste of mercurous chloride. Then
KCl
Then-
solution.
KCl
KCl solution. Okay. After taking this, you have to insert. What you are inserting? Platinum wire. You are inserting a platinum wire to make electrical contact. Okay. So to connect to the device, we will insert a platinum wire. So this is construction of calomel electrode. How many openings are there? Inlets.
Two inlets.
From one inlet, what you will take?
Hydrogen gas.
Hydrogen gas. Evaramma? Is
KCl.
that? Two inlets are there. From one inlet, what you will take?
KCl.
KCl. The other inlet, what you will connect? You will connect to?
SHE.
You will connect to
Salt bridge.
salt bridge. You will connect to salt bridge. So that is the construction of calomel electrode. Students, what is corrosion? Corrosion. You can tell
Destroying of metal.
destroying of the metal. When the metal will destroy? When the
Due
decay
to
of
chemical or electrochemical environment.
when a metal is exposed to the chemical or electrochemical environment, so the decay of the metal takes place. Okay, ma, that is called corrosion. Okay. So write any two causes and disadvantages of corrosion. So when metal undergoes corrosion, what are the disadvantages, ma? Tell me any 2 points.
Loses malleability, ductility.
It loses the properties, valuable properties like electrical conductivity, malleability, ductility. Okay, loss of the metal is taking place. Okay, any other point, ma? Disadvantages?
Efficiency.
Efficiency will be decreasing. Okay, very good. Students, what is filling Betworth rule? You remember the rule? Based on volume of the metal oxide, we discussed filling Betworth rule. Anybody remembering? Students? Filling Betworth rule. Hello?
Ma'am,
What
if the volume of the if the density,
If the volume of the
Metal oxide.
if the volume of the metal
metal.
is greater than the volume of the
metal oxide. If the volume of the metal oxide is greater than
volume of the metal, it forms a non-porous
non-porous layer. Okay. Next, if the volume of the metal oxide is
lesser than the volume of the metal,
the
it
volume
forms
of the
a
metal
porous layer.
porous layer. Okay. Okay. Students, what is liquid metal corrosion? Liquid metal corrosion. In dry corrosion, we discussed 3 types: oxidation corrosion, corrosion by other gases, liquid metal corrosion. How liquid metal corrosion takes place, ma? What is liquid metal corrosion?
Ma'am, corrosion to something like sodium or something.
Sodium. Okay. Okay.
Corrosion to molten metals or something.
Tell me how liquid metal corrosion takes place. Either liquid metal will diffuse into, penetrates into
The metal,
solid metal, or solid metal is dissolved by
the liquid metal.
liquid metal. Okay. Okay. Students, tell me any 1 or 2 difference between dry corrosion and wet corrosion, ma? Students, dry corrosion,
Presence and absence of moisture.
presence of moisture.
Absence.
Corrosion of metal takes place in presence of moisture, that is wet corrosion. Dry corrosion,
Absence of moisture.
absence of moisture. Corrosion in metal takes place in absence of moisture. Any other point?
Process of corrosion is uniform.
Process of corrosion is uniform in dry corrosion. Wet
It is
corrosion,
non-uniform in
non-uniform in wet corrosion. Okay. Students, what is cathodic protection? Cathodic protection. How you will protect the metal? What is cathodic protection? Cathodic protection. How we are arranging the metals here? How to protect metal? Arrangement, you tell me. What is cathodic protection?
I'm making the
Base
metal into a
Okay. The protective metal, what we are doing here? Base
we are
metal.
covering that with zinc or
Base-
something. Zinc tin.
Base
be-
metal, base metal, base metal.
Making it to behave like a cathode.
Cathode.
How it will become cathode? Tell me. Base metal, how it will become cathode?
By connecting it to
By connecting to
more reducing
more reducing
elements that are above the
elements. Okay.
SHE.
So we are connecting. Yes, very good. We are connecting the base metal to the other metal. We are taking a more active metal than base metal. It should be more active than base metal, more anodic to the base metal. Yes or no?
Yes, ma'am.
That is cathodic protection. What is sacrificial anodic protection means what, ma? Sacrificial anodic.
The more anodic metal
The more anodic metal
flow sacrifice itself.
sacrifice itself means it will undergo oxidation reaction. So that electrons are gained by the base metal, undergoes reduction reaction, act as a cathode. So since this more anodic metal is sacrificing itself, okay, and undergoing corrosion completely. So this protection method is known as sacrificial anodic protection method. This anode is known as sacrificial anode. Student, what is impressed current cathodic protection method? Impressed current cathodic protection method.
Ma'am, we provide electricity to make the metal into a cathode.
Cathode. We provide electricity to act as the metal as a cathode. No? So we will apply electrical energy here. Okay. So directly, so that we can convert the corroding metal from anode to cathode. Now, what are applications of galvanizing, ma? Tell any two applications. Any 2 points, ma? Galvanizing where we are using. Tell me some
Iron
article.
sheets, wires.
Iron sheets. Iron sheets, sheets, okay. Any more, ma? Any more applications of galvanizing?
Buckets.
Buckets, okay, very good. Any more?
Pipes,
Pipes, okay. Pipes, buckets,
holes, screws.
holes, screws, okay, very good. Students, what is mean by hot dipping?
Ma'am, we
Hot,
dip the metal into a liquid zinc or more active element so that when it sacrifices itself and saves the base metal.
okay, hard dipping process means, ma, we are dipping a base metal into the molten coating metal, ma. So that molten coating metal that should have here a low melting point compared to the base metal. So that we have to follow compulsory here so that we can protect the base metal. Okay, hard dipping means, so dipping the base metal into the molten coating metal, So what is the importance of tinning, ma? Importance of tinning. Where we are using this tinning process? Importance of tinning. Applications, tell me. Importance of tinning. We are giving tin coating on iron.
Corrosion control.
Corrosion control will be taken place. Okay, some application you tell me.
To produce a
Tin
metallic
is-
coating in
tin
industry.
Tin is non-toxic, ma. Tin is non-toxic. Tell me application, importance. Tin is non-toxic. Very good application is there, ma. Tell me. We are using storing food. Very good, ma. We are taking for storing food and packing food. Okay, na? So that is the importance of tinning because tin is non-toxic in nature. Students, what is electroplating? Depositing of
Coating metal on the
coating
surface
metal
of
on
base
the
metal.
surface of the
Base metal
Electrolysis.
to
base metal by the process of
electrolysis.
electrolysis. By the process of electrolysis. Students, what is electrolysis, sir?
Electric energy into chemical
Electrical
energy.
energy is converted into chemical energy. Okay. So part A is completed, ma. That is completely like a definition part. So part B is long answer questions, ma. You have to write. Okay, this is like a lengthy questions only. You prepare from handwritten notes and you write neatly in the exam. Completely you write. Okay, you will get enough time. What is galvanic? First question. What is galvanic cell? Explain the construction of galvanic cell with electrode reactions. Students, you have to write first what is galvanic cell. Okay. So what is galvanic cell? What you will write definition? What is galvanic cell definition? It is a device. Hello.
That converts
Converts
chemical to electrical
Chemical
energy.
energy to
energy
electrical.
to electrical energy. Okay. So you write construction, ma. So they asked construction. Okay. And after construction, you have to explain here reactions, electrode reactions. That is anode and cathode, oxidation, reduction reactions. You have to write the reactions. Then after reactions, you write what is EMF. So already I told you in galvanic cell 5 points. So first is construction. Second is observation or working of galvanic cell. That is electrode reactions. Third is function of salt bridge. You write like one line you write, it maintains the electrical neutrality in both the solutions. Then fourth is representation you write. Fifth is what is EMF you write. Okay, na? Next, compare between cell and battery. Students, what is cell? What is battery? Tell me. What is cell? What is battery, ma? Hello? Hello, students. What is cell? What is battery?
Combination of cells is
Combination of cells is battery. Okay, what is cell? Tell me. What is cell? Now galvanic cell construction, you know. What is a cell?
Combination
Anode
of
and cat.
Combination of
anion and cation.
ions.
aniona. Aniona. Combination of
Combination of
anode
Anode and cathode.
anode and cathode. Combination of anode and cathode. So classification of batteries already you know, ma. Primary and secondary batteries. Students, you learn these points, ma. So these points you learn. Okay, that primary cells and secondary cells, you write these points. Primary cells, these are non-rechargeable and meant for single use and to be discarded after use. So these are rechargeable and meant for multi-cycle use. So in this primary cells, cell reaction is not reversible. So in secondary cells, cell reaction can be reversed and primary cells cannot be rechargeable. Secondary cells can be rechargeable. Primary cells are less expensive, secondary cells are expensive, and primary cells can be used as long as the materials are active in their composition. Okay, ma. Secondary cells can be used again and again by recharging the cell. Okay, examples you write, like Lange cell, lithium cells, and the secondary cells, lead acid cell, nickel cadmium cell. So that points you learn and write. Okay, na? That are this part B. Second question. Okay, classification of batteries. You write primary batteries, you write the points, all the points. Secondary batteries, you write all the points with examples. Okay, na? Now, Explain the construction and working of lead acid battery. So first you have to write the construction. Okay. How to write the construction? We are arranging 6 cells in series. So each cell we are taking a lead. Okay. Anode, lead oxide cathode, and we are using we are separating with the stripes of wood. So like that we are taking 6 cells. 1, 2, 3, 4, 5, 6. So 6 cells we are arranging. Okay, in series, and we are dipping that in the electrolyte dilute H2SO4. We are dipping in electrolyte dilute H2SO4. So you have to write the construction. So then after construction, you have to write working of lead acid battery. So working of lead acid battery, you have to write. So already I told you, discharging, charging reaction, you have to write. These reactions you have to learn perfectly. Okay, discharging reaction, charging reaction. Okay, then you have to write. You have to write discharging, charging reactions and limitations of lead acid battery. Limitations of lead acid battery. So students, what is the limitation of lead acid battery, ma? Students, what is the limitation of lead acid battery? What we are taking electrolyte here? Electrolyte is? Hello. Sulfuric acid.
Sulfuric acid.
Tell me limitation. One limitation is there.
Sulfuric acid is harmful.
Corrosion
and,
due to H2SO4.
Due to this H2SO4, sometimes the battery it will undergo corrosion. Okay, the fumes from the battery, the acid fumes, it comes. Okay, it comes out. Means surrounding the battery starts corrosion. Okay, na? So to prevent this corrosion in battery, so what we do, we will use the we can use the sealed cells. Okay, so in that way we can control here. Okay, we can prevent corrosion. So limitation is sometimes what happens means due to the evolution of that fumes from the acid solution that we are taking a dilute H2SO4. So sometimes the corrosion will be taken place in the battery. Okay, no? So that is the limitation. Compare primary and secondary cells. Already we discussed. Explain the construction of lithium ion battery with the relevant reactions. So you know the construction of lithium ion battery. Okay, see the students here. Diagram I have not given here, but it is there in handwritten notes. You take the diagram. So the lithium ion battery, we are taking anode is, what is anode, ma? What is anode, cathode, electrolyte? Tell me. Anode is, students, what is anode?
Graphite.
Graphite, very good, ma. Anode is graphite. Okay, cathode is?
Lithium cobalt oxide.
Lithium cobalt oxide. Lithium cobalt oxide. Okay, ma. Cathode. Electrolyte is? Lithium salts will take, ma. What is that? Students, electrolyte. Lithium tetrafluoro. Lithium tetrafluoroborate.
Borate.
Lithium tetrafluoroborate, that is the lithium salt we will use as electrolyte. Okay, so we will construct lithium ion battery. We will take anode as graphite, cathode as lithium cobalt oxide, and we will insert this anode and cathode in the electrolyte, that is lithium tetrafluoroborate, and will connect this anode and cathode to the device. Okay, ma? That is the construction of lithium ion battery. So what is the cell reaction? What is the cell reaction, students? How the lithium ions are moving, ma, during discharging, charging? Tell me. Hello? So first we will, we discussed, tell ma, tell.
Cathode, from anode to cathode when discharging.
Discharging time, discharging time, lithium ion moves from anode to
Cathode.
Anode to cathode. Flow of electrons from? Again?
Cathode.
During discharging, I am asking you.
Left to right or anode to cathode. Flow
Anode
of
to
electrons.
cathode only. Flow of electrons from anode to cathode. From anode to cathode. Okay. So lithium ions movement? Lithium ions movement from during discharging anode to
Anode to cathode.
cathode. Okay. During this charging time, you tell me?
Cathode to anode.
Cathode to anode. The lithium ions moves from cathode to anode and flow of electrons from cathode to anode. So here the reaction ma anode. So that is it is undergoing oxidation reaction ma. Okay, loss of electrons from lithium. So I wrote N Li plus N electrons plus carbon. Okay na? Okay. So cathode. So here cathode, that is lithium cobalt oxide is there no. So this is gaining electrons ma. Li 1 minus N COO2 plus it is the movement of lithium ions from anode to cathode. Okay na? So it is here it is gaining electrons and reduced to the lithium cobalt oxide. Lithium cobalt oxide. Now students, this is discharging or charging reaction ma? Tell me. It is discharging reaction or charging reaction? LiNC plus Li 1 minus N COO2 gives rise to carbon graphite plus LiCOO2. Lithium is losing electrons ma. Here anode. What is the reaction?
I'm discharging.
Discharging reaction. Okay. So this is the discharging reaction. Okay. So you write these reactions, you have to learn and write. So if you write arrow mark this side, then it comes a charging reaction. Okay na? Understood no? Hello students.
Yes,
This is the discharging reaction. Ma. You learn this one and write. Okay, construction of lithium ion battery, 4th question with relevant reactions and applications already I told you that you write. Next, explain the construction and working principle of dry cell with reactions. So here also you have to write construction first. Tell me what is anode cathode electrolyte in dry cell? Already 12 o'clock. We'll start class, huh?
Present, ma'am. 63.
Present, ma'am.
64.
Present, ma'am.
65.
Present, ma'am.
Okay. 9, 34, 46 and 55 option. Thank you.